first chapter is about fossil fuels, so we're going to be talking about oil, coal, and natural gas. And then there are some newer alternative fossil fuels like tar sands and oil shale. And so I have actually some oil shale. I'm going to hit it with a hammer and show you that it smells like oil. How exciting. These are the tar sands in Alberta, Canada. And you can see that they strip mine them. And I think we had actually already talked about this a little bit when we talked about strip mining for coal. But in Alberta and Canada, it's kind of a pristine, really awesome boreal forest kind of biome. And lots of water, beautiful trees. I don't know, you can't see that right now, okay. But these dump trucks are like the size of a house, and basically you see these giant excavators here pulling the tar sands out. And what they have to do, they can turn this into a product that runs like oil, and you can make gasoline out of it. But it's called a syn fuel. It's not actually petroleum, but it runs like petroleum, so that's called the syn fuel, and we'll get into that in a second. So the tar sands or oil sands, they basically have this bitumen in them, and you can strip mine them and then process it. The Keystone Pipeline, they were trying to get it extended right through here, and notice it was going to cut really close to the Ogallala Aquifer, and then it was going to go to the Gulf of Mexico, and it was going to allow. So here's the border from the United States and Canada, and it was going to allow the people in Alberta that were doing the tar sands to be able to extract the oil or make oil out of that, and then be able to get it to the Gulf of Mexico so they could export it to wherever they wanted to around the world. So they were going to use our land to do that. Isn't that nice? And it was going to go right over the aquifer, and people were worried about contamination. Plus, the way you extract the oil or tar sand is really nasty and dirty, and people weren't a big fan of that either. And so it never got passed. They really tried to get that extension, this dotted line, they tried to get that pushed through. It never happened. It finally was voted down for sure, for hopefully forever, but for a while. I think it was like last month, so this is very much current events kind of stuff. So kind of cool. The oil sands produce 1.7 million barrels of oil per day. That's a lot. Canada has the third largest proven oil reserves. And so the United States is a major purchaser of that. And so by us getting our oil from Canada, we reduce our foreign dependence on oil. So it lessens our conflicts with the Middle East. So that did have some positives, but it had some big negative ecological problems. Because usually when you drill for oil, you just have an oil rig and you pull the oil out of the ground. So it's a little less destructive on the habitat. But we're going to talk about a lot of the pros and cons. So fossil fuels, yeah, they're non-renewable. Basically, we're using them faster than they can be replenished. I think we all know that. So anyway, we can make them into electricity, and we can store them. They're very good for that. As far as our use of each, in this order, we use oil, coal, and then natural gas. And oil is number 1 up there because of transportation reasons. Coal is number 2 because of electricity production. And then natural gas comes in and fills in and can be used for both of those things. And then also for home heating and cooking of your food. So developing nations use a greater portion of their energy for subsistence activities. In developed countries like the United States, we're going to use our fossil fuels and our energy for industry. And so that's a big thing. Most of the energy used in developing countries at the domestic home level is just used for cooking, right? And they're often going to use, fuel wood, right? So they're going to go out and get firewood and burn it in their house with terrible ventilation, and then get carbon monoxide poisoning and die. Do you remember that? And the little huts that they have as they cook their food. Sorry. Fossil fuels in the United States, they supply 82% of our energy needs. And I know we talked about how the United States is kind of a jerk, and that we don't want to agree to climate talks. There's a huge climate. There's a conference of parties that's going on in Paris right now. It's the COP21. It's the conference of parties. It's the 21st year they're doing it. And so I think this actually might be like the time that we decide that we're going to start agreeing to some kind of CO2 mitigation. I mean, maybe, maybe not. But Greenland's melting like crazy. You have all these Pacific island countries that are losing their habitat and their land. Like, these people won't have, like, a country to live in anymore. And combined with that, with a crazy climate that's happening with storms and blizzards and hurricanes, I think, and then now the scientific community is more, not that there was ever a lack of consistency within the scientific community, but, like, finally people in the political world have gotten on board with people in the scientific world. And so, I don't know. We seem like really big jerk faces, but you have to understand that we have way more fossil fuels than the other developing countries. We have more coal than anybody. We have second most natural gas, and then we have a good amount of oil. And so Germany, they don't have any oil, so they don't have a reason to be like, you know. So they're like the #1 in the world for solar, but they don't have a lot of the other resources that we have, and we have so many of our own fossil fuels. Like, it's hard for us to get on board. Like, Japan doesn't have anything. They got volcanoes and earthquakes, okay? And so they're importing everything. They have a really good motivation to get some wind turbines, but we don't have that because we still have quite a bit of fossil fuels left. So, yeah, they dominate our energy use, but we have a ton of them. So there's just kind of a reason we're jerks. Anyway. Industrialized countries use way more energy, 100 times more, because we're using it in industry. Half of the world's proven oil reserves are in the Middle East. And so, like, you have to know who has the most of everything. So let me tell you that. Who has the most oil in the Middle East is Saudi Arabia. So Saudi Arabia has the most oil. And then Russia has the most natural gas, and we have the most coal. We have the second most natural gas. If we look at average energy consumption per capita, remember per capita means per person. So if you look at that, the United States is in the highest category. This is Norway right here. The reason Norway is so high is because it's cold there and they have to heat their homes. And so Saudi Arabia, the reason theirs is so high is because they have to desalinate their water. So they're using their oil because they got more oil than God, but they don't have any clean water. So they're having to cook their water to get their to get the salt out of it. So they're either distilling it by boiling it, or they're using their oil to power reverse osmosis. They should get with the people at Dasani and ask them for tips. That's not funny, but it kind of is. And then you notice right here along the equator, in the developing countries, per capita energy use is in the lowest category, right? And another, I mean, not just that they're developing, they also have lots of fresh drinking water because they're at the equator, so they have rain, right? But then also, they don't have to heat their homes because it's warm. So those both things, they cut down on energy use. So energy return on investment, I'm going to be talking about that a lot today. Not every bit of energy that you put into oil extraction, for example, actually is available to you. So some of the energy is lost as you dig for stuff and you process it and you ship it. So the energy return on investment is actually how much energy you have to use. So anyway, the EROI can change. It can improve as technology improves. And so as we get better at extracting oil, or we maybe do it a little bit differently, we can get more oil out. And conversely, as we do the whole, we pick the apples off the tree that are lowest and easiest to get to first. When we do that, each apple after that is harder to get to. That's the whole marginal cost of the blue N&M thing. So oil, the energy return on investment in the 50s was 30 to 1. So we got 30 units of energy for every 1 unit of energy we invested. I mean, that's a good deal. Then at 20 to 1, now we're at 11 to 1, because now we're having to drill offshore. We're having to go dig up by Santa Claus's house. I mean, we're looking everywhere for oil now, and it used to just bubble up out of the ground like on the Beverly Hillbillies.
Teachers, please pardon the interruption one more time. The students who are part of the Step Up, Step In initiative, students who are on the Step Up, Step In advisory team, if you could report to A108 at this time. A108. That would be our Bartow Youth Action Team and some student council members. Thank you.
All right, so where do we get these fossil fuels from? I'm going to show you how we make coal, and I'm going to show you how we make oil, and then I'm going to tell you how we make natural gas, okay? So all of these things, when we talked about climate change, we had said that the carbon that was being put into the atmosphere as we burn fossil fuels had been sequestered in the lithosphere, had been stored in the lithosphere for 300, 400 million years, okay? So let's go back in time. When we made coal, what happened then, I mean, the Earth was completely different. Dragonflies were like the size of eagles, and the Earth had 30% oxygen in the atmosphere. It had huge trees, huge insects, crazy stuff. First dinosaurs were happening. I could just tell you all about it, but I won't. Anyway, so you had lots of these swamps and everything, and so the woody debris would fall into swamps, and it had this anaerobic sort of situation, right? Not a lot of oxygen. When you have aerobic respiration and decomposition, you don't make fossil fuels. You make CO2 and body heat, and nothing good comes from that as far as like making a fossil fuel. So anyway, all this stuff gets buried under water, and then over time it gets buried by sediments, and it never fully breaks down. And since it never fully breaks down, that's why you can put it in Plant Bowen and turn your lights on. If it had been fully broken down, all that would just be floating around the universe as little waste heat. See what I mean? So anyway, that woody debris gets buried, and over time, this kerogen stuff, that's the energy compound in these fossil fuels. Anyway, so over time, you get you a nice little coal seam, okay, and that's how that works. Over here on this other side of this picture, let's talk about where we get oil from. Okay, think about places that have oil right now, okay? Places off the coast of the ocean. You go to the beach. If it's not like a nice beach where a lot of rich people stay, like there's an oil rig off the coast. Have you ever seen a lot of oil rigs off the coast in the ocean? Then you probably just go to Florida. Like if you go to nice touristy places, you won't see them. But if you go somewhere where there's no tourists, they're everywhere. Have you seen them?
They're like in Louisiana.
Oh yeah. It's like who goes to the beach in Louisiana? Oh right. In California, they're very common, especially if it's not like a real nice beach. So anyway, also think about places like Texas, North Slope of Alaska, well, that's on the ocean, right? And then like the whole Middle East. You know what all those places have in common? They were what is it? What is it? What? They're all either ocean or used to be ocean. Do you know why? Do you know why the Middle East is covered in sand? Oh. Yeah, and so that's why it has a ton of oil. You never thought about that, did you? Anyway, so how do we make oil? People are like, so you don't make oil from dinosaurs. Like none of this came from So anyway, these little plankton in the ocean, they die and they go to the bottom of the ocean, and over time they get buried up in sediment, and they anaerobically or without oxygen start to decompose. And so over time, that kerogen forms. Instead of it being a hard solid substance, it's oil and petroleum. And so there it is. Now, if you think back to methane, natural gas, it's a greenhouse gas, right? It's formed from growing rice, it's formed from landfills, it's formed from the melting of permafrost. It's 20 times more powerful as a greenhouse gas than carbon dioxide. Is that all coming back to your memory? Anywhere that you have decomposition without oxygen, you're going to make methane. So methane is formed in pockets in coal seams, and it's formed in pockets in oil. Methane doesn't have a special way it gets made. It just gets made anywhere that you have anaerobic decomposition. So if you want to find natural gas, you're going to find it with oil, and you're going to find it with coal. That's why coal miners have to have the carry in the coal mine, it's methane, and it blows up. And then that's why the Deepwater Horizon blew up, because there was too much methane in the well. So methane is all up down both of these. It doesn't have its own special little picture. Okay? It's also formed at the bottom of the landfill. Okay? Like in Cartersville, if you go to the dump, you just see like this big, there's a flare, and they're just burning the methane that comes off of the garbage juice. Yeah, that's a thing. So anyway, this is so interesting to me. So there's that. That's how you make those things. So coal, you can highlight this if you need to. Coal is the most abundant fossil fuel. We have about 200 or 300 years left of it. And we have the most. Haha, go us. Anyway, how do you make coal? Well, I showed you that, but you know it has some names to it. Let me tell you about those. Peat is really common, especially in places like the UK. Like it's pretty common. They have like this kind of. It's sort of almost coal, but not quite. It's very moist and it has organic material will burn, but it has too much water in it, and so you have problems with incomplete combustion and carbon monoxide problems with peat. It also makes a lot of soot and it doesn't burn very well. The amount of energy you get off of it kind of isn't that great. All right, lignite coal is lousy coal. It's kind of not. It has a lot of moisture in it, and it hasn't been under too much heat and pressure, so as far as how much energy or in its bonds, it's not that great. Bituminous is okay. Bituminous is kind of B grade to me. Do you see where I'm getting these letters from? Bituminous is B grade, and then anthracite coal is where it's at. It's awesome. It's A grade. So anthracite coal is fantastic. It has almost no moisture, huge amount of energy. Doesn't have much sulfur, doesn't have much contaminants, but it's super rare because it has to go under so much heat and pressure. So there's always like the, catch, right? Most of the coal burned in the United States is bituminous. Anthracite is popular when you can get it. At Plant Bowling, they burn, I think it's like 2080, something like that. But it's mostly bituminous, and they get it from West Virginia and Pennsylvania kind of area. And then like the anthracite that we have, it's really more common out west, like Wyoming and Montana. Does that sound right, Lauren? Do you know about that? Do you really? Very cool. You can go home and tell your dad about it. Ask him what percentage is the anthracite and bituminous. I feel like I'm on the right track there. But anyway, most of our coal is going to come more from the eastern seaboard because of the long distance. But the better quality coal is, the Powder River Basin that way out west. So anyway, like I told you guys, that peat is sort of organic materials been broken down, but it's not really coal yet. It's wet, it's near the surface, not very well compressed. You can't run a power plant off that. I mean, that's not a thing. But like households, yes. And over time, it's going to turn into coal. And there's 4 different kinds, and I just told you about those. Natural gas, petroleum. I got to tell you about some petroleum. That's what it touched right there. When those little phytoplankton die, there's thousands of different kinds of phytoplankton and zooplankton that die and get squished at the bottom of the ocean. Do you somehow think that they just magically all turn into gasoline that you can put in your car? No. So anyway, what ends up happening with petroleum is after all that stuff gets squished and turned into keratin, or whatever. Anyway, come here so you can see this. If you can't see it, turn. I don't want to make that sound, okay? So if you can't see this, move so you can. So what you end up doing after all those little things in the ocean get buried and make it squishy, it's like black jello. That is the consistency that we're talking about here. You basically cook it, and hundreds of different kinds of hydrocarbons. Some are big hydrocarbons, and they have a really high boiling point, like diesel fuel or something like jet fuel. So they boil, like diesel fuel, for example, boils at 207 degrees Celsius. Water boils at 100 degrees Celsius, okay, for comparison. Anyway, and something like liquefied petroleum gas boils at 20 degrees. So what ends up happening, you cook your oil, and all these things, it rises up, and depending on the boiling point, the things that boil at lower temperatures will rise all the way to the top. Things that boil at a real low temperature, real high temperature, stuff like tar, it stays near the bottom, and you basically siphon this off as it boils. And so the boiling part is called distillation, and that's the same water boiling desalinization one. Distilled like whiskey, right? Like that's boiling, okay? So this is distilling. The fractionalization is where you take off this part for diesel fuel, this part for naphtha, this part for jet fuel, this part for gasoline. That's fractionalization. And basically, the shorter the hydrocarbon, the lower temperature is going to boil, and it's going to rise all the way to the top of this. And the lower down here, the hotter it has to be to boil, and so it's not going to rise as much. And so you're going to pull these off, and then that's fractionalization. And the last part, like oil refining, is where you take this gasoline and you get it ready for market. So those are the 3 steps. and so basically, this is a really tall tower. It has all these tubes coming off the side, and so like all the gasoline, this part of the chamber or tower is going to be that temperature for it to condense back, and so yeah. But what you do is you boil it and you separate it off after it condenses back to a liquid, and then there's like a tray that pulls it off. So that's a little bit beyond the realm of this class, but that's how it goes down. So basically, you just need to understand that it's hundreds of different hydrocarbons, and you get a bullet to separate it. And the fractionalization part, that actually is on the test, as far as I know that they make different products out of it. How you going? That was the best project ever. I mean, it's been like 3 years ago, and I keep it in the closet because, like, it's very handy, right? So, anyway, natural gas is, like I said, it doesn't really have a special way to get made. It's methane, CH4. Yeah. Okay. Natural gas, it can be thermogenic, and when I say that, that's the natural gas that gets formed with that gets formed with oil and gets formed with coal. Biogenic gas is the methane that we make in rice paddies, and that gets made in landfills. Okay, so it has a bunch of different ways to get made. Oil shale. I need to show you some oil shale. Are you excited? I have a piece and I'm gonna hit it with a hammer. You have to close your eyes because it really will get in your eyes. So everybody close your eyes. Because oil volatilizes, right? And it evaporates. Pass it around, pass it that way, pass it that way. Oh, yeah. If you wait till the end of class, it won't smell. Because the oil evaporates, right? Volatile organic compounds. Isn't that super interesting? Wait, what is that? Oil, shale. So shale, S-H-A-L-E. Okay, and then it has the oil in it, but when I break it apart, see the oil has vaporized. So I have to break it up into the middle because it has vaporized. So it's like a piece of coal? No, that's not coal. It's oil shale. Coal is really light. Have you ever felt coal? No. Oh yeah. That's not the same thing. I have some coal. I have a massive collection of rocks. Is that weird that I'm just walking over here and be like, where's my coal at? I think I have some in here. I might take it out. I got it. Brand new. We should light this on fire. You have to crush it up first. You have to crush it up first. Let's crush it. Do it. I don't think that's actually cold. No. I don't know. It's really light. But like, this is, you're like, this is cold. It's just really good cold. Hey, Ken, I have to prep 2 different labs today for Amy. Can you explain? You know who's helping you? George Mountain. Can you ask him how it goes? What is, let me give you my notes. Here. Oh, yeah. Just take that and give it back to tomorrow. Alright? Yeah, I just realized that, I have to